Graphing two sets of numerical data with ordered pairs, you can determine if there is a relationship. If a relationship exists, you may be able to use a line, linear function rule, to estimate or predict values. A scatter plot may show relationships and can sometimes be explained by correlation. Here are the three types of correlation that we're going to talk about. Positive correlation. As the x values increase, the y values increase. Negative correlation. As the x values increase, the y values decrease. And then no correlation is just when it's all random and there's not really any type of correlation. So here's what those lines would look like. If it's a positive correlation, what kind of line do you think is going to be? Positive. There you go. If it's negative, it's going to be nice, negative. If it's no correlation, no line, you're not going to draw a line through the graph if it's no correlation, or it's going to look pretty like flat. Actually, no, not even that, because that'd be 0. No correlation, you can't really draw a line through it. Something else I need you to add is that we can also say strong or weak. When we think about strong or weak, it's strong if it's really close to the line that you can draw through the scatter plot. It's weak if the dots are really far away. So let's look at these. You could draw what we call a line of best fit through this. So it would be like something like that. Is that positive, negative, or no correlation? Positive. Okay, that's easy. And this one is kind of up in the air. Would you say that's strong? Are the points close to the line, or are they far away? Strong or weak? Probably pretty strong, yeah. You got kind of like a straggler over there, an outlier. That's a little bit farther away, but for the most part, it's pretty strong. Okay, let's look at the middle one. You've got your data. It's kind of spread all around. Positive, negative, no correlation. No correlation. So you really can't effectively draw a line through this. What? No correlation. So we're not going to say strong or weak for this because there's not really a correlation to begin with. Next one. You could draw a line of best fit through that. It should be straight. Mine's not because I'm doing it on my iPad. Positive, negative, no. Negative. It's going down. And would you say it's strong or weak? Strong. This one is more strong. So like if that one is strong, maybe we should really say that the other one over here is weak. But in general, these points are for sure fairly close to the line of best fit, and so we would say strong. So we already kind of started talking about this. I drew in some lines. When two sets of data have a positive or negative correlation, you can use a trend line. Trend means how things are generally going, right? To show the correlation more clearly, a trend line or line of best fit, so we got two names for it. You're going to hear me use both. Is a line on a scatter plot drawn close to the points that show the correlation. You can use a line of best fit to estimate a value between two known data values or to predict a value that is outside the range of known values. So here's our prediction words, and I need you to know the difference between these two. This is most commonly where I see a lot of mistakes with this. Students getting these words mixed up, but if you know your would be prefix? No, that's not prefix.
Yeah, it would be
prefix. Okay, then you'll be good to go. So interpolation is the estimation of a value within the known data points. Interpolation. Inside the data. Extrapolation would be the estimation of a value outside the known data points. So x, like if you say the interior of a house, it's the inside. If you say the exterior of the house, it's the outside. So if you know in and x and what those two parts of speech mean, then you'll be in good shape. So we're going to make a scatter plot today, and we're doing it by hand. We will use our graphing calculator later in the week. The table shows the average attendance at a school's varsity basketball games for various years. Make a scatter plot and write an equation that models the average attendance at varsity basketball games as a function of the number of years since 2000. So that's x, function of x, and attendance would be y. You already have the graph scaled for you. How nice. That won't always be the case. You might need to look at your values and see how it's changing. I want you guys to look. Do you see this weird thing happening right there?
Yeah.
Can someone raise your hand and maybe explain to me what in the heck does that mean? Catherine?
Basically, it's telling you that it's skipping up to a section that starts at 4.
Yeah, and some bright person, can you please tell me why that makes sense? Aaron, why does that make sense? Okay. We're going to go ahead and graph these points. Notice it says years since 2000, so like this is 2000. This is 2001, just so we're clear. So please go ahead and plot those points. 2,488 would be your starting point. Do your best to approximate it. Looks like you've got 7 points to graph. It should not make a straight line. Not perfectly straight anyways. Next thing, it says use your linear model. Okay, we haven't actually drawn in a linear model yet, but you can tell that this graph is moving kind of in a linear fashion. So what we're going to do is draw a trend line or a line of best fit. It's going to be best if you use a straight edge to do this. So if you have a straight edge like your binder or even like part of your calculator is straight, use that to draw a straight line. Here's what you want to think about. Listen, please. You want to try and get about the same number of points on each side of the line. So you want it to go through the middle. Like here might be a good spot because you've got 3 on that upper left side and then 4 on the bottom right side. So try and get about the same amount through each. Please use a straight edge if possible to make sure it's straight. We need to make an equation for this line. In order to make an equation of a line, you have to have 2 points because then you can find the slope and then you can find the y-intercept. So I'm going to choose 2 points that I see on this graph. Trying to get it as simple as possible here. So this one is good. Right there, it's about 1 in 500. I'm going to put like an X there. It's not a point on the graph. Or it's not a point in the data set, but it's a point on the line, since our line is like an average. So notice that none of these points actually really go through the line because we're averaging. And then, what do you think?
3 and 4.
4 and about 602. Okay, sure.
I would say 602.
So I'm going to use those 2 points to find my slope. So just like you would before, we're going to use the slope formula to figure out the slope, which is why you need a calculator today. because it's not going to work out perfectly, I don't think. So my 2 points are 1, 500, and 4, 602. I'm using my slope formula. Oh, it works out perfectly? Oh, man.
Because it's 100.
Yeah. So go ahead and plug in your points. So it's exact or no?
I did it different. I said
Go ahead and give me, don't leave this as a fraction actually, since we're using a data set and it's like real life numbers here, it's what it's supposed to be. Go ahead and divide it. So if like you have 100 over 3, go ahead and divide it and get the decimal. Okay? Where does it look like this line starts? What point? 475. So really I should have done this probably up above because that says predict a game's attendance in 2010. So I might have to move that work. But so we've got y is equal to 34x plus 475. It starts at 475 and goes up 34 people per year. So if we're using the equation to predict in 2010, what am I going to plug in into my equation and where? Suffolk?
You're gonna plug in 10.
Yeah, 10 for x. Because years since 2000 would be 10. So I didn't leave myself space because I should have done this above, but I didn't. So I'm going to draw an arrow. So we're going to do this right here. So y is equal to 34 times 10 plus 475. Well, that would be 340 plus 475. So our prediction is that in 2010, there would be 815 people in attendance. Okay, can someone please tell me which one it is and why? Colby, which one is it?
Yes. It is extrapolate because 10 is not on the graph.
Not only that, is it in the table?
No.
So I'm just going to clarify this. On the table goes from 0 to 6, right? 10 is outside of that.